So for this new feature in V0070, we're actually going to look at the Explorer tool. So real quick, what you just saw me is dragging and dropping a project file into the annotation window. You can also do that by going to File, Import, Open Project right here. And then what you can see is we actually have some annotations already within the project. Here I'm modifying the transparency. You can also hide annotations if you wanted to, or if you wanted to change from all labels to just select labels. Right now we have the Coral label selected, and we can modify just this and not the other ones. We have 4 images with some number of annotations between each. If you double click on a different image within the image window, it'll load up those annotations. After you load up the annotations once, they'll be cached in memory, so it'll load up a little bit faster each time you do it. Bigger images take longer to load. So down here you have your different labels. So if I wanted to have the selector tool, I can select one, or by holding the control, you're doing left mouse button click, and you're selecting different annotations. As you can see, if you zoom in with the zoom wheel and then do with your right mouse button, you can pan around. You can see that these guys are selected based off of their animations, marching ants. You can change the transparencies and look at those guys. Anyways, once you have these annotations selected, you can change their labels if you wanted to, just by changing the label down here. And you can see that only these are being modified because these are the ones that are selected. Hotkeys for changing the labels, if you forward, is Control WASD, just like a video game. So A and D move left to right, W and S moves up and down, but we only have one row, so those don't do anything. You can also, I just deselected just by double clicking anywhere. I can select by doing Control and then the left mouse button to create a rectangle like you would in a File Explorer. And once you have these selected, you let go of the mouse button, or it'll select those. And then you can add on to it by doing Control and selecting another one. I'm just going to change back that to the Coral. So yeah, that's that. So what we can do now is open up this new tool called Explorer, and this is going to open up in a new window. And the cool thing about this is you can actually move it to another screen, and you can still have some functionality here. So you can still zoom in, you can pan around. You cannot change the transparency, everything else is static, none of the hotkeys work. But what you can do is you can actually come over here to the annotation viewer, and we'll talk about that more, is if you actually just Control and then right mouse button click, you will actually automatically zoom to that particular annotation, and you can also see that it's selected. So this kind of gives you an idea of like what's going on with more context. You can change the size of the annotations that are currently within the annotation viewer using this slider. And again, Control right click on each of these to select them and also view them in the window. If we have something like this, we can change the annotation by doing, again, the Control WASD, or just by selecting a new annotation. And the similar functionality that you would have in the annotation viewer as you have in the annotation window. So if I wanted to create a rectangle, I do Control and then left click and drag, and I can select all these annotations. And if I wanted to, I could change the label. I can select one and hold down Control left click to add more. The one tool that this has is if you do Control and then Shift, you'll select all in between. And just like in a File Explorer, if you have some selected, you can do Control to select these, and then another Control Shift to select all of those. So within the annotation viewer, you can sort by a couple of things. So by label. So if they already have a label, you can see that we have these different labels: Coral, Diver, not Coral, and they're kind of already put in those categories. You can do it by image if you wanted to do that for some reason. We only have one image loaded. I like to keep it labeled because it's visually a little bit more consistent. And up here you can see that this is how we're actually loading up different image annotations within the annotation viewer. And in a second I'll show you the embedding viewer. So this is sort of a conditional. You can, select all. You only have 4 images, or you can deselect all and select one by one just by left-clicking it. For now, we'll select all. You can select the different annotation types. All of them are included by default, and then the labels, again, all are default. So that sort of controls the total amount of data that is within your current session. So if I press apply, it loaded instantly because we already loaded the annotations previously by going to each image, and they were already stored in memory. If we had new images that we hadn't gone to before, it would take a second to crop them and then display them. So now you can see that we have all the different annotations from those 4 different images by label. And if we go by image, you can see that it's per image instead. Now that we have all of these, you can do some stuff. You could move this slider window out of the way entirely and change the annotation size. And then you could just annotate in this particular view if you wanted to do so. But one cool thing about this feature, this new tool, Explorer, is the ability to display annotations within, if you want to call it, feature space. So a feature is something that we are deriving from this sort of individual image. You can go to isolation mode so if you have a couple of these guys, you can isolate them if you wanted to, and you only see them. That becomes more important in a second. But a feature is basically we're taking this image that belongs to the annotation, and it could be a patch, it could be a rectangle, it could be a polygon, and we're basically passing this image through some sort of algorithm. And the algorithm can be very basic, like just calculating the color features, or it could be using some sort of existing machine learning model, computer vision model. And we're basically passing these images through this model and getting a feature vector. And I'll go ahead and display this because it'll make a little bit more sense. For now, color features are the most basic, and they're the easiest to calculate. You don't have to load anything up. It's just a quick algorithm that calculates a number of different color and texture features from each image. They're all deterministic, and we can actually take the features that are calculated from each of these images and then plot them into feature space, and then map them back down into 2D space so we can view it here. So just to recap, we're taking one of these images or all of these images, passing it through an algorithm. That algorithm is then creating a feature vector, and the vector is multi-dimensional. So normally plot points in 2 or 3D, but these feature vectors have more than 2 or 3 coordinates. Sometimes they can be 1,000 coordinates. So we're going to use some sort of feature reduction technique like PCA or TSNE or UMAP to be able to plot them back down in 2D space. So we're going to take these, use color features to create a feature vector, and then plot that back down into 2D space. PCA has no parameters, so you can just press apply embeddings. And basically what it's going to do is it's going to extract features for all of the images in the session. And then it's going to calculate the 2 most prominent principal components, and then use that as a basis to plot this in a 2-dimensional space. So I'm going to bring this down to a little bit. And now we can kind of move around in the embedding viewer. So again, right click and drag allows us to pan, and then zoom wheel, scroll wheel allows us to zoom in and out. And what we can do is we can select one with left mouse button click, and every single annotation that you click afterwards is going to be sort of stored here, but it's not selected. If you want to kind of unselect and remove or go exit out of the isolation viewer, you basically just double mouse button click left. So if I select a couple of these guys with control left mouse button to create a rectangle, you can see all these are selected. If I just single select somewhere, it'll unselect them, but they'll stay inside of this isolated view. If I go to show all, then I lose that isolated view because they're no longer selected. So I can see all these that are selected, and I can do some stuff with them. For example, if I wanted to change their label, I could just by selecting one of these guys. If I wanted to focus on, a subset of these, then I can focus on these, but you still stay in this isolated mode. And basically that's it. So you can kind of move around and you can view these different annotations. This is an interesting area where you have a lot of red and blue, which corresponds to fish and diver. And again, these are sort of grouped based off of the features that we calculated, which are color features. So if we actually look at these different annotations, you can see why this kind of teal and red label sticks together because visually they're somewhat similar. In some of the diver images, you've got fish, but it's considered a diver label. But visually they're very similar. So that's why they're grouped closer to each other in feature space. And for example, we were to come down here and double click to exit isolation mode, and I just select these annotations. I can see that these are very visually different from the things that are over here or over here. And you can basically kind of come in here and either modify labels or update labels. So for funsies, I'm just going to select all of these and I'm going to press review, and let's press apply. And this is actually really important. So everything that you do within the Explorer is not actually saved in the actual project until after you press apply. So if I press clear preview right now, you can see down here that there's some annotations with preview changes. If I press clear preview, they all go back to what they were previously. But if I select all of them and I change the label, and then what did I miss these guys? And then I press apply, then you can actually see right here we're actually modifying all of the labels within the project. So this is sort of starting from scratch right here. The underlying features are still the same, even though the label is different. The features come from the images themselves, not the labels. So now we can kind of start playing around with this. PCAs are really cool and fast technique, but I prefer TSNE or UMAP, and these are different parameter values that you can modify that will just change where the points are relative to each other in feature space. So if I were to change the exaggeration, you'll see that it changes it a little bit, but if you change the perplexity, it'll change it a significant amount more. I like kind of lower values because it clusters them really based off their similarity in local neighborhoods. So you can just go from local neighborhood to local neighborhood and kind of play around with it. So you can do find potential mislabels, but it's not going to do anything because they all have the same label right now. If previously we had given these guys a bunch of labels, find potential mislabels will actually find which annotations appear incorrect based solely off of the fact that, like, if this is one label and this is another label and they're right next to each other in feature space, that doesn't quite make sense. Sometimes it does, but maybe it doesn't. And that's just a quick way of identifying, ones that are maybe incorrect and that you should pay attention to. And then over here, I'll show you the next tool, which involves using a machine learning model. So I'm going to go over here and I'm just going to select this particular area, and I can see that all of these are very visually similar. They all belong to the diver class, and I can just do that. I can press apply if I want to, but I can also just leave it at how it is for now. And I can come in here and I can look at this. I can see that these are also diver. Cool. So it looks like probably this particular region of space is going to belong to this sort of diver or maybe even fish, as you see here. I can see, so these are patch annotations. And traditionally, patch annotations are whatever the center point is. That's what the label is supposed to be. So, like right here, I can see that the point lands directly on the fish. And again, I did control and right click to do that. Whereas right here, if I do control and right click, I can see that the patch contains fish, but the point itself is not on the patch. Sorry, the point itself is not on the fish. So in this case, these two would actually be considered fish. And then these would be considered, that one has a fish, these would be considered, in this case, diver. And this is just a toy example, so it doesn't really matter. Now that we have some labels, we could actually say, find potential mislabels, and, it's going to highlight some of these regions. And then you can also change these parameter values. So if I only want to find, fewer, it should do that. And this is really useful whenever you have a lot more labels. Review uncertain is also really similar, and then find similar. So find similar is if we press this button right here and say maybe we don't have anything labeled whatsoever, we can actually do the find similar, and it'll actually identify images based on their features that are similar in feature space. And again, you can kind of change the parameter value, so it should be the 10 most. It looks like it's more than 10 though, so you can see this one. Yeah, it's more than 10. And you can see that, like, why is this one? Why are these, sort of selected? The background, color, and texture might be similar. Some of these I would consider sand, and therefore not coral. Some are coral, some have fish in it, for example. So if I do this, that one, these all contain fish. And then I can do, again, sort by label to organize it. These, in my opinion, are all coral, and we can select these really quickly. I'll say that's a coral, I'll say that's a coral. Actually, let me call that coral, and then what you can do again is come in here and, where was it? Right click it. It's coral. I'm gonna do that. And all of these are not coral. There you go. So anyway, so what I would do is I would come in here and start labeling each one as, what class category they are, using the annotation window on your right-hand side as a reference. So for me, I can actually see that this guy, I labeled these, I know that it's a fish. It's really small, but I can see it behind. There's another example right there. So I'll label that as fish, and I'll label these as diver. And then we'll do this selection, and then we'll move on to the next thing. That's a fish. And again, if you're familiar with your own data set, you'll be able to spot out, whatever the differences are. Some other things, so maybe we want to create a new class category. You can just come over here to label window. The label window itself actually comes from the annotation window, or the main window. And it has the same exact functionality, so we can create a new annotation if we wanted to. We could delete one, you could modify it, merge it. If you have a bunch of labels, you can sort them, filter them so you don't have to see it. So maybe I only want to look at things that are coral and not coral. Then you have this ability just to play around with these two. And the hotkeys only goes within these two. So all that functionality is still there. What I'm going to do is I'm actually going to use a pre-trained model that was previously trained on this data set, and that makes it really powerful. So you can use a default model, and these are just things that were trained off of, they were just trained on very generic images, and we're repurposing it. But I'm going to use a model that I previously trained on this data set. So I'm going to go back to where that data set is, where that model is. In my case, it's D3 classification, weights, and then best. And I'm just going to load up that model. And then you have two different ways of doing this. You can look at the predictions, and that's useful because we can then use this review uncertainty tool, or you can use the embedded features. This is, if you're familiar with a convolutional neural network or a transformer, the first portion of the model is actually just used for deriving features. So looking at the actual image, understanding visually what's going on, or finding key features that tend to be associated with different class categories, and that's what embedded features are. So we're basically just taking what the first part of the model is sort of distilling and saying, like, hey, these are really useful features, we should use these. Predictions is using the second part of the architecture. So it's actually taking in this image and it's getting its classification, its predictions for each one, and then mapping those into image space. So it produces slightly different views, and it could be useful for different reasons. So if I do embedded features, I'm going to press apply embeddings. It's going to extract those features. A cool thing that's going on behind the scenes that you're not seeing is that whenever we extract these features, they're actually being stored inside of a small database right here. And whenever maybe you change between color features in a new model or a different model, these results are being cached, so that way you can actually load up the results again really quickly. So it just finished calculating those embedded features, and we can see that they're sort of mapped in these different areas. And now if we compare these to the color features, they might be grouped in a slightly different way, a slightly better way, slightly different way. So we can see that these are all diver, that's great. I can see that these are all coral, and I can see that we already have one label right here. So it's probably going to be that all of these are very similar because they're similar in feature space. That's correct. And then I can come over here, and I can see, like, oh yeah, these are all very similar except for a few. So I'm going to select these. I'm going to call that coral. And then I'm going to come down here. I'm going to see that these are all fish very clearly. And then this, let's see, you can call that coral. I'll put it there. And yeah, so that's one way of doing it. And again, you can find potential mislabels. Maybe you find things. So here's a pretty good example right now. So it's based off of what the differences of labels are. And you can see like right here, these are all the exact same label and they're all similar in feature space. So none of these actually get picked up. This gets picked up because it's a red one located next to a bunch of green ones. And if we actually look at it, you can see that it looks just like coral, but it's got a fish in it. That's why it's called coral. That one actually kind of similar dark texture patterns. That's probably why they're next to each other. We're going to leave it as. And then, same thing. If we have these areas right here, you've got a bunch of white and red. So really, review should probably be left as it should be excluded. Maybe I'll make a change for that. But you can come in here, and we can see that these are all fish. These are all fish. That is not a fish. So we will change these to fish. And let's look at this. So this is always an interesting area. You don't really know what it is unless you're familiar with the scene. It's underneath this larger coral. And actually, if you look at it, there's actually a sea urchin right there, and then maybe some rubble and some soft sediment. So I'm going to call this not coral. And it's kind of interesting because it puts it in a place of feature space where it's like close to coral, but then close to these things, which are probably going to be not coral. So if we go over here, no, these are all fish. Pretty exactly. Yeah, these are all fish. So that was a pretty good mapping. And then let's see what this is. I can tell it's a fish because there's a little bit of red right there. And also I labeled it, so I'm going to say it's a fish. Now, this is really cool because you can very clearly see now that we start to label it, they are clustered in ways that make sense. If we change the embeddings, you can see that it loaded up really quickly because the features have already been cached, and that's usually the most expensive part. So we can change these parameter values, and really all it's doing is changing the dimensionality reduction process. So now you can see you've got these sort of distinct clusters, but they're much bigger. We can come in here and just select this entire region, and we can see that the review are the ones that we're looking for right now, which are black lined. And for me, I would say almost all of them, except for maybe these two, are diver, which is pretty cool. Now, if we switch from embedding features to predictions and press apply embeddings again, you can see that we're actually extracting the features again. And it's basically just running all of these patches through a very small convolutional neural network. And then it's going to map them into feature space. And the cool thing about having predictions set is that if we actually hover over one of these points, you can actually see that we have more information. So you can see top predictions at the very bottom underneath the line. It actually gives us an indication of what the model thinks that this thing is. And, if you used a, pre-trained model, one of these guys, the predictions would be vastly different. So we're using an existing model that was trained on this data set. It also means that you can do review uncertain based off the confidence. So if we do review uncertain, it'll actually select a subset of points and display them. And where they're located within feature space is also really informative because you can see that these guys are all on the edge of this particular cluster, which means that it's sort of on the fringes and therefore it's potentially an edge case. And when it comes to relabeling annotations, finding the edge cases, the ones that the model is less confident about, relabeling these as ground truth, as a user, as a scientist in the loop, is actually what pushes the needle in terms of increasing model accuracy. So for example, we've got a bunch of annotations over here. Let's select these guys. We've got a bunch of annotations over here, and if we hover over here, we can actually see that it's sorted based off of confidence score. Well, maybe. This is 99, that one's 100. Rounding error, whatever. You can see that, it's very confident that all of these belong to the coral class category. This one is not, though. Let's see. This one's incorrectly confident, and so is this one. So that's actually not coral, and that's fish. So even though the model's confident doesn't necessarily mean it's correct. But being able to modify the areas where the model is less confident is what really helps in terms of accuracy. Because if we just increase the total amount of annotations in this particular cluster or this particular class category, you're not really moving the needle much, right? So if you have a bunch of these annotations, having more of these annotations doesn't make the model more accurate. But being able to sort of come back and say, you know, this, I'm actually certain that this is a fish. I'm certain this is a fish, even though it's uncertain. This is what really moves the model in terms of accuracy. So that's not coral. So for example, this one is not coral, but it's 60%. So by having predictions set, you can do this. If you use embedding features, you shouldn't be able to do this. That's pretty much it. If we switch back to predictions and we do review uncertain, we can change the confidence threshold value. So we want to say, you know, find us where the model is less than 99% confident, which is going to be, you know, a decent amount. 0% margin. What is it? Is it 1? Yeah, so it'll select the vast majority of annotations. It'll just show that basically all of this region right here is what you saw before, that it's very confident, although it might not be right. So if you wanted to find the most confident, if you wanted to find the most confident, right now you would find the ones that are not highlighted, anything underneath 100, and then you come over here and see, like, you know, yeah, it's just dark blue, it's nothing. But if you want to find the one that's the least confident about, you know, anything below 50%, then these are ones that are, you know, sort of the least confident of all of the ones that are here. So you have that available to you. The last one is UMAP, and again, this is just another way of plotting it from high-dimensional space to two-dimensional space. And it takes a little bit longer. If we go over here, you can see that it is loading. Cool. So just another way of viewing it. Once you actually calculate UMAP once, it's a little bit faster every time after that, which is nice. And you can see that it really separates depending on the variables that you kind of provide into. So let's increase the min distance to get it slightly bigger. Cool. And again, come in here and look at these guys and say, like, yeah, this is all not coral, and those are all fish, so we're good with that patch. I'm going to come in here and just select this subsection, and again, these are all coral, these are fish, these are not coral, and then these are the ones that need review. I think that these are not coral. I think that these are coral, and then that one is fish. Come over here and see that this is a fish, and that's a coral. And then the last few, that one for sure is a coral. If you don't believe me, there you go. And then this one is I call this not coral, even though it looks like it was a coral. Maybe it's just covered in algae. And we are done. And obviously you have the home button, which just brings you back to view. So now you can see that we have all of these labeled. And finally, we can press apply, and that'll actually apply it. If we press clear preview, it'll remove all of the work that we've done and keep everything as is. If we press exit, it'll just exit without saving anything. So I'll press apply, and you can see on the right-hand side, all these things are updated. And if we go back to just the main window, if we press exit, you can see that the label window at the bottom is going to be transferred back over here where it belongs. And now we have all of these different annotations that we created. So I'm going to save the project with Control-Shift-S. You can see the project was saved. Otherwise, you can just come up here and save your project. It does the same thing. Now we can kind of come in here and look around at the annotations that we just created. So this is one of them that we saw. And here I'm clicking on one annotation, doing Control and the left and right arrows, and it will basically just bring you one by one to each individual annotation. You can see in the bottom right here, we're on number 17 out of 149. If for some reason I want to go back to annotation 1, I can just type in 1. I'm going to go to annotation 1, or whatever number you want. And yeah, if you want to look at an image metadata, you just hover over it in the image window. And if you want to get a preview of the image, you're not going to be able to see it. Off screen, if you hold the Control key and you hover over these, you actually see a small thumbnail of the image, so you can actually view it before you load it. just super useful when you have really big images. And yeah, that's pretty much it. So this is a really useful tool if we had a much bigger project. For example, let's load in, this is pretty much we're pretty much done, but if you wanted to stick around, if we have a much bigger project, we can load that one in. Oh, that was me, that was dumb. Now we're importing more annotations. So instead of 4 images, we have 68 images. And right now this computer is using a CPU, not a GPU. So if we load up Task Manager, I bring it into frame, and you can see in the Performance tab, we have just a single GPU. If you had an NVIDIA GPU, you'd be able to come down here and select your device. So because everything's running on CPU, it's pretty slow. So you can see right here, we've got some more images and more annotations. It'll take a second to load those. If we were to go to Open Window, Explore, you can see that we have all these annotations just for this image. You can select all. It's going to take a second. But for now, we just want to select a couple of them and press Apply. It's going to crop those. And we can see that we've got a lot more annotations, color features, PCA, because it's faster. We can extract it, and now instead of having, 800 annotations, we can have significantly more. You can see that it appears a lot different. We come over here and we add some more images. Just probably need to change how you view these. Because depending on your monitor, you might only see 2 or 3 rows, which is annoying. You can see that whenever we add more annotations to the project, the embedding's clear. But when we actually do this, we're actually only calculating embeddings for some number of images. So we already had 771, but now we're computing 1269. So it was that database shown previously that sort of caches it during a project. So now we have significantly more within the embedding viewer as it finishes. And you can start to see some interesting patterns. You can come in here and start to look around things. There is a bit of a slowdown the more annotations that you have, so just be wary of that. It might be slightly slower depending on how much you have in the computer that you're on. Having a GPU would be great. You can see, because I didn't move the monitor, him over here, you can see these are all fish, but they're not labeled that way. So maybe you come in here and label them as fish. And that is pretty much it. Similar. So you can see a lot of these guys. If you select multiple and you press Find Similar, you actually are looking at the centroid between these, not just the individual one. So you can see that they're similar because it's actually all around the same area within the image. Yeah, that's pretty much it. So this is available in 0.69 with updated features in 0.70.